Hello, class. As you know, I usually send you an article about some new research that's going on, and I decided to go a little bit of something different this week. I saw something that was just so galactically stupid that I wanted to talk to you about it, and it's not so much the cool things of what we're doing in science, it's just more like, don't do this. This is really stupid. And the stupid thing I saw was a 24 karat gold plated Cybertruck. I saw some advertisements about this, and this is a terrible, terrible idea when it comes to a chemistry standpoint. It is one of the dumbest things you can do, with the exception of if you're going to gold plate any sort of vehicle, the only practical application for that is for it to sit dry and safe in a museum. That is the only thing you should use that for, because you will create something called pitting corrosion. So let me showcase the bad idea first. So you take a Cybertruck, and these helpful individuals will take and remove an oxide layer, and then they will very graciously attach a gold layer to it, so the gold layer is touching the stainless steel, electrically connecting it to the stainless steel. And I think one of the only good things they've done here is put a small amount of cobalt to harden the gold, because so gold is a very soft metal, and they did that right. So you got to give the people here a little bit of props there. So because gold is a soft metal, and because of that, it's really easy to break through this layer. So by any mechanical means. So I mean, you back into a bush with this truck, you're gonna have a scratch on it. So once you get that scratch, and once that gets wet, you can get pitting corrosion. So I'll go in a second, but maybe I'll show my age here. But I remember the movie Back to the Future, and Back to the Future, the time machine was a DeLorean, and DeLoreans are also, at least the shell, are made of stainless steel. And they did this back in the day too. They gold-plated DeLoreans. And lo and behold, there was lots of pretty pitting corrosion with the gold-plated DeLoreans. So, and this here is a gold-plated DeLorean, and it is in the National Automobile Museum, and that is the perfect place for it. So if you gold plate your car, keep it in the museum. So any rich person that's watching this video, if you're not my student, and if you are my student and you can afford a gold-plated car, keep it in your garage or put it in your personal museum. Do not take it to the grocery store to buy something. Do not go to Home Depot to get mulch, because you are asking to damage it. So, okay, let me tell you a little bit more about the Cybertruck. So I looked it up, and so let's see, I got so many windows open. So Tesla has the 300 series stainless steel. And so what does stainless means? It means it's corrosion resistant. So it does not stain, it does not turn rusty. So when you see rust on something, that's the stain. The stainless steel is anti-stain, and then the anti-stain. So here is the 300 series stainless steel, and there is no convention to how we number these. They're just names. There's not like a scientific way that we organize the different steels. So we could give them numbers and give them application. For instance, 316 is used for food and drug, for instance, and 304 is just general anti-corrosion resistance. You can see here it's got 20%-ish chromium, 10% nickel, a little bit of carbon, and various other elements. And the balance, you're looking, 70% or more. Obviously more than 70% iron. So steel is more iron. And where did steel come from? Well, we learned how to make iron, and problem with iron is one easy way to make it stronger is to add a little bit of carbon, usually around 2%. And when we use the word steel, we usually mean carbon steel or structural steel, which I said is 2% carbon. And oh, there's another word. It says austenized. So what is? So the cybertrucks said it says Oh, it didn't say austenized. Okay, I'm sorry. If you hear the word austenized, that means you dunk it in water. So if you've seen old movies where they're making swords, right? You have the blacksmith putting the sword in the forge and whacking it with the hammer, and sparks are flying. That's just another way to purify it. The sparks flying, those are typically magnesium, calcium silicates, also known as slag. So you can mechanically push the slag out of it. If you make it in a blast furnace, the slag floats to the top. So it just depends on how you want to do it, like in the old forges. So you can mechanically hit it, or we make it in factories now. And if you add about 2% carbon, you get steel, and it greatly improves the strength of the iron. Why is that? Because the carbon atoms sit in between the iron and the metallic bonds, and it makes it harder to move the iron. So it makes it a lot stronger. And a little bit of carbon goes a long way, and that's by mass. So the 2% carbon, that's by mass for the steel. So why do we care? I mentioned pitting corrosion, and I'll talk about that in a little bit. But let me talk about activity of metals. So here shows standard reduction potential. So corrosion, like iron rusting is a corrosion. It's an electrochemical reaction. So it means it involves the electromotive force of electrons moving from one atom to another, or one atom to an ion. And so, like I said, corrosion is an example of an electrochemical reaction. And there's a few ways to stop corrosion. So you can coat the metal in something, because usually when for many types of corrosion, the material has to get wet. I mean wet with water. And if you coat the material, the water can't get through the layer, like they put the oxide layer on the Cybertruck, which they remove to put the gold on that. So removing some of the corrosion resistance there, that will prevent corrosion. So making sure it never gets wet, like keeping your car in the garage or in a museum. But a very common way also is called a sacrificial anode. So the anode corrodes and the cathode grows. So you lose the anode and the cathode of the battery, or of the electrochemical reaction. A battery is an application of corrosion. So the anode goes away, but if you put a more active metal on the whatever it is you want to protect, for steel, a very common thing you put on steel is zinc, and that's galvanized steel. So galvanized steel means it's coated in zinc, and the zinc will corrode first, and that is known as a sacrificial anode. You sacrifice an anode, and then the sacrifice of the anode protects whatever it is you are trying to keep. So you see here, zinc is here's zinc. So iron is here, and the further down here, the more active the metal. So lithium is a very active metal, and then here's iron. So if you put zinc over iron, the zinc will corrode first. If you put manganese over iron, it'll protect that first, and so on. So magnesium. So if you wanted to have zinc and you wanted to make sure the zinc wouldn't corrode, you could attach magnesium metal for it. Then the magnesium would become a sacrificial anode. So AU is gold. You can see gold all the way up here. So the problem with gold plating something, and you think this is actually a very smart move because you're putting a very corrosion resistant coating on something. That works until there's a hole in that. And so gold is a very unreactive metal. And if you electrically connect it to the stainless steel will corrode to protect the gold. So actually putting gold electrically attached to to something, you are going to catalyze the corrosion. So not only are you gonna like it's you're gonna get these corrosion in pits, but the pits are going to be catalyzed by this. So let me show you pitting corrosion. Oh, this stainless, sorry, I got so many windows open. This is also my second time making this video. So, okay, here we go, pitting corrosion. And so pitting corrosion, and the thing with pitting corrosion, it forms pits. It forms like little cavities, and you typically don't want these at all. This is one of the least desirable form of corrosion, because when you have corrosion on the surface, like you kind of know where it's at, and the corrosion occurs over a greater surface area. You have a pitting corrosion. It happens in a very concentrated spot, and then the pit can go deep, and that can cause structural damage to the metal. It can also blow out side to side. And let me back up. And so here we have the pitting corrosion. We have, although this has this cathodic reaction here, but I mean, imagine this light blue line here is gold. And once you get a hole in this gold layer, you are now, and that layer gets wet, right? So you take your beautifully gold-plated Cybertruck, and you back out of your car, you scratch it on your bush, and suddenly there's a little tiny hole in that gold layer, and then it starts raining. I mean, luckily it never rains here in Hawaii, right? Or I guess maybe if you had this in Arizona, that or somewhere, if you in the Sahara Desert, maybe you could get one of these, but certainly here in Hawaii, I personally haven't seen one of these gold-plated Cybertruck with my own eyes, but we'll see what happens, if and when people start doing this. But once you get through that gold layer, and gold is soft. Remember, gold's a very soft metal. It's very easy to get through a gold layer, and suddenly, and also remember, there is no oxide layer because they removed that to put the gold on. That's a good idea actually, because that would be easier to peel off the gold, so that way the gold can form a metallic bond, right, with the rest of the stuff. So, but anyways, once you get through here, then now you have corrosion occurring here in the pit, and the stainless steel. So the stainless steel is the anode. The anode corrodes, and the cathode grows. So you're gonna have water here, water and oxygen in the air. So the electrons go from the iron, and it's more than the iron is going to corrode with stainless steel. Then since gold is a less reactive metal, it will cause the nickel, the molybdenum, or whatever they alloy in it. They're not really specific in the Tesla. They just say 300 series. So the whatever other metals are in there they are now vulnerable to attack, because they are going to sacrifice themselves to protect the gold. And so all of those metals less active than gold are going to corrode away, and then they're going to form an oxide layer outside of this, and it's probably going to be rust. I mean, it's because steel is still mostly iron, but you might get some of the other oxides, the nickel and molybdenum oxides, for instance, on the surface here. So the iron and other metals will give up their electrons, and then the ions will dissolve into water, and then the ions will migrate to the surface. Well, they'll combine with oxygen, and then the electrons from the metal, as it goes through the electrically conductive stainless steel, through the very conductive gold. Gold conducts electricity very, very well. It's not the best conductor atom-wise. Silver is actually a better conductor, but gold is still really good. It conducts better than copper, for instance. But then you have that very efficient conducting metal gold giving it the electrons here, and then it forms the other non-gold oxide layer in the corrosion. And now you have this pit, and that's growing. It might go side to side. So, but either way, the corrosion is localized, and it's just this I'm saying for this is a bad idea. This is a very, very bad idea to do that. So, whoever, if you're watching this, do not buy a gold-plated Cybertruck unless you want to keep it in your garage or in a museum. The chemistry of this does not check out. I do not recommend this. I don't think you're going to find many people who will recommend this. So, like I said, it's funny to see this, and I wish the people that came up with this idea, would take my chemistry classes. So then you could learn about this stuff and realize the mistake in your ways through this wonderful subject of chemistry, right? Okay, so I hope you enjoyed my soapbox tirade and in my memory lane to the good old Back to the Future, to the good old DeLorean days, and full circle seeing now the Cybertruck. And it kind of does look like a DeLorean in a way. It's kind of has that same futuristic, sleek kind of look. So I like that. But anyways, I hope you enjoyed this little more lighthearted, maybe a little less technical sort of interesting tidbit about life. And as always, I hope your week is going well. I hope your weekend goes well. If you're having any issues academically, with this class, of course, with other classes or academic issues in general, I've been in the system for 18 years. I'm pretty familiar with a lot of things. If you're running into any food or housing insecurities, there's no way that you're going to do well in this class if you're dealing with that. If you're having any mental health issues, let me know. I will always do what I can to help. Look after yourselves. Look after your mental health. Mental health is very important. So not many people talk about it as much, but it's very, very important. And if you need help with that, let me know and I can connect you with some people. So with that in mind, I hope this message again finds you very well. Hope you find it this amusing, as amusing as I do. And I hope you are well in general. Aloha.